Let us solve another example. And the given equation is C of k is equal to 3 raised to k minus 1 plus 2 raised to k plus 1 plus k, where k is greater than or equal to 0. For the first step, we count the number of terms in the given closed form expression. We have 3 terms, and these are 3 raised to k minus 1, 2 raised to k plus 1, and k. Then the step 2, we add 1 for the constant term plus 0. So that would give us 4 terms in all. Then the third step, we have to write the 4 equations. So what are these 4 equations? The first one, we have C of k is equal to 3 raised to k minus 1 plus 2 raised to k plus 1 plus k. Then the second equation, we have C of k minus 1 is equal to 3 raised to the quantity k minus 1 plus 2 raised to the quantity k minus 1 plus 1 plus the quantity k minus 1. So we solve this. 3 raised to, that becomes k minus 2 plus, we copy the other terms. Then we solve the second term. That would give us 3 raised to k minus 2 plus 2 raised to k plus the quantity k minus 1. So we now proceed to the last term. That would give us 3 raised to k minus 2 plus 2 raised to k plus k minus 1. So we now have the second equation. Then the third equation, C of k minus 2 is equal to 3 raised to the quantity k minus 2 minus 1 plus 2 raised to the quantity k minus 2 plus 1 plus the quantity k minus 2. So we solve the third equation. That would give us the 3 raised to, that would be 3 raised to k minus 3. Then we copy the other 2 terms first. And then we proceed to solving the second term. That would give us 3 raised to k minus 3 plus 2 raised to k minus 1. Then we copy the third term. So finally, we get the third equation, 3 raised to k minus 3 plus 2 raised to k minus 1 plus k minus 2. For the fourth equation, that would be C of k minus 3. However, in the reference book that we are using, it only solves up to the second order relation, which is C of k minus 2. However, in the steps that I am providing, it will always give us a constant in the right hand side. So I prepared a fourth video which considers C of k minus 3 in the solution, and that would lead us to a recurrence relation, a third order recurrence relation with a constant on the right hand side. But for this video, we'll just use the first 3 equations to get the second order recurrence relation. So for step 4, we'll have to solve the system of equations involving the first 3 equations. So we have to eliminate the first term, which is what? That would be 3 raised to k. That would be the first term. Using the following equations, using 1 and 2. So how do we do that? That would be, we subtract from 1 3 times the second equation. So here is the solution for that. We have c of k minus 3c of k minus 1 is equal to the quantity 3 raised to k minus 1 plus 2 raised to k plus 1 plus k minus 3 times the quantity, the terms in the second equation, that would be 3 raised to k minus 2 plus 2 raised to k plus k minus 1. So we solve for the right hand side. That would give us, we have 3 raised to k minus 1 plus 2 raised to k plus 1 plus k minus the quantity 3 raised to 1 times 3 raised to k minus 2 plus 3 times 2 raised to k plus 3k minus 3. Then we continue. We copy first the first set of terms, 3 raised to k minus 1 plus 2 raised to k plus 1 plus k minus, so that would be 3 raised to k minus 2 plus 1 plus 3 times 2 raised to k plus 3k minus 3. So solving this equation further, that would give us 3 raised to k minus 1 plus 2 raised to k plus 1 plus k minus 3k minus 1 plus 3 times 2 raised to k plus 3k minus 3. So we now distribute the signs, or we multiply each term with the negative sign. So we get negative 3 raised to k minus 1 minus 3 times 2 raised to k minus 3k plus 3. So we rearrange the terms. That would give us the next equation, and that is equal to 3 raised to k minus 1 minus 3 raised to k minus 1 plus, that would be 2k plus 1 minus 3 times 2k plus k minus 3k plus 3. So 3k minus 1 minus 3k minus 1, that would give us 0. So we are left with these terms: 2 raised to k plus 1 minus 3 times 2 raised to k plus 3 plus k minus 3k plus 3. So we continue solving this. We factor out the common factor between 2k plus 1 and 2k times 3. That would give us 2 raised to k, that's the factor. Then what is left is 2 minus 3. Then we copy the other terms. So we continue solving this, and Once we are done, we will get the equation 4. That would give us equation 4 for this step. Okay, so for the left hand side, that would be c of k minus 3, c of k minus 1. Then that would give us the right hand side is equal to negative 2k minus 2k plus 3. That's our equation 4. Then we do the same for using equations 2 and 3 to eliminate the first term, 3 raised to k. And how will we do that? We subtract 3 times equation 3 from equation 2. So we now do it. So c of k minus 1 minus 3 times c of k minus 2 is equal to 3, the quantity 3k minus 2 plus 2 raised to k plus k minus 1 minus the quantity 3 times the quantity 3 raised to k minus 3, then plus 2 raised to k minus 1 plus k minus 2. So we distribute the constant 3. We copy first 3 raised to k minus 2 plus 2 raised to k plus k minus 1 minus, so we distribute 3. So 3 raised to 1 times 3 raised to k minus 3 plus 3 times 2 raised to k minus 1 plus 3k minus 6. So we do the next step. So 3 raised to k minus 2 plus 2 raised to k plus k minus 1 minus, that would be 3 raised to k minus 3 plus 1 plus 3 times 2 raised to k minus 1 plus 3k minus 6. So that would give us the next equation, 3 raised to k minus 2 plus 2k plus k minus 1 minus 3 raised to, that would be k minus 2 plus 3 times 2 raised to k minus 1 plus 3k minus 6. So we now have the next equation, 3 raised to k minus 2 plus 2 raised to k plus k minus 1. We distribute negative 1, negative 3k minus 2 minus 3 times 2 raised to k minus 1 minus 3k plus 6. So we will regroup the different terms after this. That would give us we just remove first the grouping symbol for the first set of terms, and then the next step is we have to regroup and this would give us 3 raised to k minus 2 minus 3 raised to, not regroup, we have to rearrange the terms, so that this would give us that equation. So here what we do is we eliminated the term 3 raised to k minus 2 minus 3k minus 3k minus 2. So that would leave us with the equation 2 raised to k minus 3 times 2 raised to k minus 1 plus k minus 3k minus 1 plus 6. So since we want to factor out the common factor for 2k, we can rewrite that as 2 raised to k minus 1 plus 1. Okay, so that's just 1 minus 1, 1 minus 1. So we still have k. So we continue with that, and we'll be able to factor out the 2 raised to k minus 1. So that would give us 2 minus 3. Then if we continue solving that, we should have an answer of negative 2 raised to k minus 1 minus 2k plus 5, which would become our equation 5. So we'll use equation 4 and 5 to eliminate the term 2 raised to k in the next solution, or in the next phase. Okay, so I hope everything is clear up to this point, so that we can proceed to the next step. So the next step is we will now have to eliminate the term 2 raised to k. So let us now eliminate the term 2 raised to k using equations 4 and 5. To do that, we multiply negative 1 to equation 4 and multiply 2 to equation 5. So we add these two equations, then that would give us this solution. Negative times the quantity c of k minus 3 c of k minus 1 plus 2 times the quantity c of k minus 1 minus 3 times c of k minus 2 is equal to negative times the quantity negative 2 raised to k minus 2k plus 3 plus 2 times the quantity negative 2 raised to k minus 2 raised to k plus 5. Then we proceed. That would be equivalent to that equation. So we just manipulate first the left hand side. Then we distribute 2 in the next step. That would be negative c of k plus 3c of k minus 1 plus 2 times c of k minus 1 minus 6c of k minus 2. Then we copy the right hand side. So we combine similar terms here. That would give us negative c of k plus 5c of k minus 1 minus 6c of k minus 2 is equal to the right hand side. So the next step, we can now manipulate the right hand side, or we will manipulate the right hand side. So that would be distribute the negative sign. That would give us that equation, and then we copy the other set of terms. Then we distribute 2 to all the terms. That would give us negative 2 raised to 1 times 2 raised to k minus 1 minus 4k plus 10. Then that would give us 2 raised to k plus 2k minus 3 plus negative 2 raised to k minus 1 plus 1 minus 4k plus 10. So that would give us negative 2k minus 4k plus 10. So we can subtract the 2 raised to k. That would become 0. So we are left with 2k minus 4k minus 3 plus 10. Then we combine the 2k minus 4k. That will give us negative 2k. And then negative 3 plus 10. That would give us 7. So we now have a right hand side equivalent to or equal to negative 2k plus 7. Then we multiply all sides of the equation by negative 1 so that we will get the same answer as what is shown in the book, and that is c of k minus 5c of k minus 1 plus c of k minus 2 is equal to 2k minus 7, where k is greater than or equal to 2. That's it.